Assalamu alaikum.
Islam.
Goodbye, how are you?
I'm doing well. How are you doing?
Alhamdulillah, I'm fine. So, what is your good name?
My name is Furkan Shazad.
Okay, Furkan Shahzad, I'm going to share the link with you. Just give me a sec, then we can start with our topic. Okay?
Alright.
Okay. Furkan, I have shared the link in the in call messages. Please join it.
Okay.
So, Furkan, it's me, Shiraz, and I am an experienced online tutor of the physics, tutoring the Cambridge students across the globe. So, have you joined the link?
Yes, I have.
Okay, right. So, goodbye. So, in the today's lecture, we are going to talk about the power, concept of power. We are going to derive the equation of the power, and we will talk about its unit. Right? So, Furkan, can you tell me that what do you know about the power? What is meant by power?
Power is the amount of energy an object has. It can be calculated by work over time.
Yeah, very good. So, goodbye. Come to the slide number 2.
Okay.
So, here we are going to write down about the definition. First, we would write down about the definition of the power. So, is my writing visible to you?
Yes, it is visible.
Okay, right. So, in the most simple wording, we can say that power is actually the ratio of work done, work done, and the second one thing is the time.
Time.
Yeah, very good. So, it's the ratio of the work done and the time taken to do the work, right? So, it means that if we have the work done and we have the time, so we can find out the power. So goodbye, the power is represented by the P. So what would be the formula of the power?
P equals to W over T.
Okay, good. So P is equal to W over T. So goodbye, let me know that if we talk about the work, so can you tell me that what is work? How we can define it?
Work is a thing done by an object. The energy is done by the object. For example, if if I move the
Hmm?
ketchup bottle across the room,
Yeah.
that'll be work.
Yeah, right. Very good. So, in the simple words, we can say that work is basically the measure of transfer of energy. So, it's the measure of transfer of energy. Just like if you carry your school bag on your back toward the school. So, it means that you are basically transferring the energy toward your bag. So, can you tell me that from where your energy is coming, how you are basically producing the energy?
It's the chemical energy.
Yeah, so basically you have your muscles and your muscles have the chemical energy. So when they would be doing any kind of the work, so basically they are converting their chemical energy into the energy of the bag. So Furkan, can you tell me that what type of energy would be there in your bag when you are carrying your bag? So what type of energy is in it?
Uh, Kinetic.
Yeah, so when it's moving, it's having the kinetic energy, and also the bag is having certain height as compared to the ground. So would there be any kind of the potential energy in it?
Yes, gravitational potential.
Very good, excellent. So because it's having the height, so there would be the gravitational potential energy in the your bag. So we can say that if the work is the transfer of energy, so can we say that the power is the ratio of energy transferred to the time taken for the energy transfer? So can we write it? So we can say that it's the ratio of energy transferred to the time, right? Okay.
Yeah.
So we can say that the other one formula of the power can be power is equal to the delta E divided by the T. Furkan, why I have written the sign, this one sign? Do you know what is the meaning of this one sign?
No, I do not know. Is it angle or energy?
No, it's basically called as the delta, right? And if we talk about that, what is the meaning of this one? So it means any change, right? So this is called as the delta, and delta mean any kind of the change. Because I told you that your muscles, your body is basically losing your energy to do work on the bag. So you are basically transferring your energy toward the bag, so it means that your body is having a loss of energy. So that's why I have written the delta E. Okay. So the next one point is, if we talk about that, okay, so Furkan, come to the next one slide. Here we want to know about the unit of the power, right? So always keep in mind that whenever you have to find out the unit, so do you know we can take the help from the formula of the quantity in order to find out the unit? Do you know?
Yeah.
So it means that if we want to know about the unit of the power, so we can take the help from its formula. So Furkan, can you tell me that what is the unit of the work? Do you know?
Joules.
Yeah, very good. Excellent. So the unit of work is the joules. And what is the unit of the time?
Seconds.
Yeah, very good. So it means that we have the joule divided by second. And if we rearrange this one, so what would happen? Joules and per
Per second.
second. Yeah, right? Because we would take the second on the upper side of the fraction. So it means that we are having the unit of the joule per second. But we have another formula for the power, that is P is equal to the energy or change in energy divided by T. So we want to find out the unit from this one equation too. So what is the unit of energy?
Joules.
Right, it means that joule. Time is again the second. So it means that the unit of the power from this expression is also the same. It is the joule and the second raised to power minus 1. But goodbye this one unit, instead of using this one unit joule per second, another unit is used for the power, and that is called as the watt. Do you know this one unit that is called as the watt?
Watts.
Yeah. So watt is same. It is equal to the joule per second.
Per second.
Yeah, so this one is the commercial unit of the power, that is called as the watt, right? So have you ever seen written this type of the figures on your, you can say that any kind of the electrical appliance, just like if you have the LED and its box. So maybe you have seen that it's written just like this one, 15 and
50
the
watts.
W, right? So what does it mean?
This is 15. The power is 15 joules per second.
Yeah, so it means that the LED that you are going to use in your room is having the power of the 15 watt, or you can say that its power is the 15 joule per second, right? So this one is basically about the unit of the power. Okay, so Furkan, jump to the next one slide. Now we have
Yeah.
to talk about some other units of the power, right? If we talk about the watt, so that is a small unit of the the power. But there are some bigger units of the power that is called as the kilowatt, right? So Furkan, can you tell me that one when we use the prefix kilo, so what does it mean when we say that kilogram?
1,000.
Sorry?
1,000.
Yeah, very good,
Yes.
very good. So when we use the prefix kilo, so it means that 1000. So it means that if you have kilowatt, so that would be equal to the 1000
What?
watts, right? So most of time you may have heard that some electric motors, they have their power in the form of the kilowatt, because you know that the electric motors, they are having the quite large power. So that's why their power is discussed in the terms of the kilowatt. We have even a bigger unit for the power, and that is called as the
Megawatt?
megawatt. This one, good, very good. So Furkan, let me know that whenever we say the mega prefix, so what is the meaning of mega prefix?
Mega means 1,000,000.
Yeah, right, very good. So we can see that one, two, three, four, five, and six zeros. But it is too large. So Furkan, do you know that we can use it in another manner? We can write it in the scientific notation. Do you know about scientific notation?
Yeah, standard form.
Yeah.
1 times 10 to the power of 6.
Yeah, very good. So we can say that 10 to raise power 6 watt. So in the same way, we can also write the above one, the kilowatt. So that would become the 10 to raise power 3, right? So we can say that 10 to raise power 3 watt. Okay. So now the next one thing is, if we want to solve any type of the question related to the the power, so we can basically calculate the power in terms of the two things. If we have the work provided to us, we can calculate the power, and even if we have the energy, we can also calculate the power. Okay, so goodbye, I'm going to write down a question at the slide and you have to solve it. Would you like to do it?
Alright.
Okay, so can you tell me, suppose the weight of your school bag is just like, suppose it's 50 Newton. It's a supposed value that the weight of your school bag is 50 Newton, and the distance from your home to your school, that is, suppose the distance is equal to the 500 meters, right? And the time you take to move from your from your home to the school is equal to, suppose it is equal to the 10 minutes, right? So now you have to tell me that how we can calculate the power you have consumed while you were going from your home to the school. So can you tell me that how we can do it?
We already used W is for work, right?
No, W is basically the weight, right? It's not about the work.
Wait.
Yeah, it's weight.
So 50 times 500 to 25,000.
So yeah, very good. So first we have to calculate the work. Good. So work is equal to force into distance, or weight into distance. So 50, what is basically the displacement or distance? So it is 500.
The answer is 25,000
Yeah. So that would be equal to the 25,000.
joules.
Yeah, good. Joules. Okay. So now let me know that we have the time in 10 minutes. So can we use it as such?
No, we have to convert it into seconds because the distance is in meters.
Yeah, very good. So time, how we can convert it into the seconds?
Uh, 10 times 60. So
Very good. Because there are the 60 seconds in 1 minute. So what would be the answer?
600.
Very good. 600 and the unit is the second.
Seconds.
Okay. Now let me know that what is the formula of the power?
Power equals to work divided by time.
Very good. So what is the value of work?
25,000.
25,000. Okay, sorry, it's 25,000. Yeah. Yeah, it should be 25,000. Okay. So divided by 600. Okay. So Furkan, do you have calculator with you?
Yeah.
Okay. Please find out the do the calculation and find the answer.
It's 41.67.
0.6 and 7 unit.
Watts.
Very good. Watt. So it means that you have to consume the power of the 40.67 watt when you have to move toward the school, right? So we can say that this
It's 41.67.
oh
41.
it's a 41. Okay, right. Good. So we can change it. So it's the 41 point. Oh, sorry. Yeah. So we can say that it's the 41.16. Okay. So it's the 41.67 watt. Good. So now we can move toward the next one point. So goodbye, jump to the next one slide. Here we were using the formula for the unit, that is the watt, and watt is equal to the joule second. So now we have to define that when our power is 1 watt. So we can say that 1 watt that was equal to the 1 joule per second. So on the basis of this thing, we can say that we can talk about the concept of the watt. So we can say that if we have the if our body is doing the work of 1 joule within 1 second, so our power would be 1 watt. Got it?
Yes.
Okay. So we can say that if sorry we can okay. So if 1 joule work is done in 1 second, 1 second, so the power would be would be 1 watt. Okay. So the next one thing is, Furkan, let me know that do you have any idea about the scalars and the vectors?
Yeah, scalar quantity
Hmm?
has no direction and only has magnitude.
Good.
Vector quantities have magnitude and direction. For example, velocity.
Yeah.
The vector quality and scalar quantity is speed.
Yeah, very good. Excellent, excellent. So, Furkan, can you tell me that if I ask you that whether the power is a scalar or the vector, so what would be your answer?
Scalar. It
Yeah.
has no direction.
Yeah, very good. So we can say that if we talk about the power, so we can say that power is a scalar quantity. Very good. So we can say that power and that is a scalar quantity. Very good. Scalar quantity. Okay, very good. So, Furkan, let me know that have you ever seen that the mobile phone chargers or the adapters, they have how much power?
20 watts.
Yeah, 20 watt. Very good. So we can say that the small objects or the small appliances, just like the mobile phone chargers, they have their power in the form of the watt. So the 20 watt. So just like I gave you the example of the electric motor or the pumps. So they have their power in the form of the kilowatt. So let me know that have you ever heard about the power of the power plants? Just like the dams and those, you can say that the big power plants. So do you know that how their power is basically measured? In which unit their power is measured?
Um, I don't know.
Yeah, so that's measured in the form of the megajoule, a megawatt, right? Because megawatt is just like a quite large unit for the measurement of energy. So because the power plants they are producing a lot of energy that is used throughout the country, so they have their power measured in the form of the megawatt, right? So this is basically about that when you are going to discuss about any type of the, you can say that the energy resource, so it depends upon that how much energetic is your energy resource. So if you are going to have a big energy resource, so then you have to discuss or you have to talk about a very large unit of the power. But if you have a quite small appliance that is basically having a very small power for its consumption, so then you would say that you would discuss in the term of basically a very small unit for the power. Got it? So the next one thing, I'm going to give you a question. Another, we are going to do another question for the,
Power.
okay, right. So this one, yeah, I'm going to this one distance and the mass, and we have to, okay. Just give me a sec. I'm going to put it on the slide.
Uh,
Just give me a sec. I'm going to put it on the slide, right?
okay.
Okay. So goodbye. Jump to the next one slide.
Okay, I'll do next slide.
Okay, right. So goodbye. Read the question number 6.
How much work is done in a mass of 3 kilograms and the gravitational force is 9.8 newtons per kg is lifted vertically through 6 meters?
So do you know about the formula of the work? Because we have calculated the work in the previous one slide. So can you tell me that how we can solve it?
Force times distance is work.
Yeah. So here we have the but do you know where is the force? So do we have the force?
Yeah, gravitational force 9.8 newtons.
Yeah, but goodbye, that is basically the value of the g. We want to have the force or we can use the value of weight. So can we convert the value of mass into weight? This one is mass. So can we convert it into the weight?
Yeah, we can 3 times
Yeah,
9.8.
very good. So first of all, we would convert it with the help of this formula. So W is equal to mg. We would multiply the mass, that is the 3, with the value of 9.8. Okay, Furkan, let me know that what is the answer.
29.4.
Okay, very good. 29.4. Okay. So what would be the unit of this one? Weight?
Uh, kilograms.
No, goodbye. Keep in mind that the unit of the weight, it is basically measured in the form of the Newton, right? Because weight is about the force. Okay. So its unit is the Newton. Furkan, get it? Okay. So yeah,
Why the Newton? Why the Newtons?
because goodbye, keep in mind that weight is the same thing as the force. Okay. So weight and force are just the same things. And the unit of force is the weight. Sorry, the unit of the force is the Newton. And the weight is also measured in terms of the Newton. Got it?
Got it.
Okay, right. Good. So next one, tell me that we have calculated the weight. So let me know that how we can convert it into the work. So next one we have to calculate the work.
Work equals force times distance.
Yeah.
29.4
Hmm.
times 6
Into the 6. Let me know the answer.
times 6.
Sorry?
176.4.
Yeah, 176.4 unit.
Joules.
Very good. The unit would be the joule. Right. Good. So, okay, goodbye. The next one, let me know that can we do the next one?
Okay, let me try.
Hmm?
So in question number 7, do I have to still calculate with the gravitational?
Sorry?
Do I still have to use the gravitational force in the 7th question?
Yeah, still same. You have the given the height and you are given the mass, but you are not given calculate the work she does in lifting her body to the top of the hill. So you have to do the same thing as I have done in the previous one question. So first you have to convert the mass into weight with the help of the g, that is 9.8. Then you would get the weight. You should treat that weight as the force and calculate the work with the help of that force. Got it?
Got it.
Okay.
So 51 times 9.8. We have to convert 51 kg into weight.
Yeah, so it means that weight would be equal to the 51 into 9.8. Okay, so let me know the answer.
Of 499.8.
99.8, that is the Newton. Then we want to find out the work. So work is equal to the
Force times distance, so 499.8 times 300.
okay, so into 300. Okay, so let me know the answer.
It's a big answer. 149,940.
149
And 49.
9,000.
No, like 149. Like 149. Okay, I'll just say the numbers. 149.
Okay, sorry, just give me yeah, 1 4 9
940.
940. What would be the unit?
Joules.
Right, good. So the unit would be joule. Okay. So read the question number 8.
An electric motor does 80 joules of work in lifting a box vertically upwards through 5 meters. Calculate the weight of the box.
Yeah. So the work is provided, the distance is provided. So can you calculate the weight of the box?
Mm, how? I don't know how to do this one.
Okay, right. So we can do it. Okay. So just we have to use the formula of the work here, so we can do on the same slide, right? So we have the work W is equal to force, or we can say that it is as the weight WT into the distance or the displacement. Got it? So we are
Well,
provide
what is WT? What is WT?
just give me a sec, I can let. So basically here the capital W is the work, the small w is the weight, and the d is the distance. Got it? So
Got it.
so you are provided with the work. How much is the work?
The work is 80 joules.
Okay, so you would write 80. You have to find out the weight. And what is the distance?
5 meters.
5. So if we want to find out this one, so can we take 5 on the other side of equation?
Yeah, so the 80 divided by 5.
So weight is equal to 80 divided by 5. Let me know the answer.
16.
16?
Yeah,
Yeah.
16.
Only 16?
Yeah,
Yeah.
80 divided
So what would be the unit?
joules.
Goodbye. It's the
No, no,
weight.
this weight. No, no, this weight. This Newton.
Right. Very good. Excellent.
No, I can't see. It's like, it's under the screen. That's why I can't see it.
Okay. Right. Right. So okay. So the slide is basically, you can say that it is a little bit confined, so that's why you can see it. Okay. So goodbye. This was all about our the today's session. So can you tell me that do you have any question?
No.
Okay, so goodbye. This was all about the session, but if we talk about our mine experience, so that was very good. You are a very good boy. You are very excellent in the studies, right? So if you don't have any questions, so can we end the session now?
Yes, we can end the
Okay,
section now.
goodbye. So take care of yourself. Allah Hafiz.
Take care. Allah Hafiz.
Allah Hafiz.